We are going to find the maximum height of a projectile with this equation for its height. This is the height based on time, or h of t, and the equation is negative 4.9 t squared plus 6t plus 0.6. Now this is a quadratic equation because we have a t squared in it. There's many ways to find the maximum height, but key number one is that if it says maximum and it's a quadratic, you're looking for the vertex of the parabola. How do you do that? Well, one option is to complete the square. But with decimals and ugly numbers like this, I don't really feel like doing that. One other option is to find the axis of symmetry. And what I mean by that is that the height of the projectile, I don't know, it starts about here, it goes up and then comes back down, and this is supposed to be a parabola, right? The maximum height occurs here, and there's a line on the parabola that corresponds to that, and it's called the axis of symmetry. I write AOS for myself. There is a shortcut formula to find the equation of the axis of symmetry based on the equation. The axis of symmetry for a standard form quadratic is x equals negative b over 2a. A is the number that's in front of x squared. Now I don't have x here, it's t, but the point stands. It's a letter squared. This is a. The number in front of the bare letter, just itself without the squared, is b. And the number added or subtracted from the end with no letters is c. But actually c isn't even in here, so why am I telling you? I can plug these numbers into the equation. B is 6, so negative 6 on top of the fraction. A is negative 4.9, so that's 2 times negative 4.9. I'm going to need a calculator for this one. This is negative 6 on top and negative 9.8 on the bottom. I will need a calculator for this. Let's do negative 6 divided by negative 9.8. I got 0.612. Now, what does that mean? That's actually the time, t. Oh, I guess I shouldn't have called that x. Ideally, I should have called it t instead. That's the time at which the projectile reaches its maximum height, approximately 0.6 seconds into the trajectory. But does that tell us what the height is? Not directly, but we have function notation for the height here. So what we actually have to do is find the height at 0.612. And we do that by copying out this equation, negative 4.9 t squared, but t is 0.612, and plus 6t, that's 0.612. And we have our plus 0.6. I barely ran out of room there. And now we can do this on our calculator. You can do it all at once. I'm going to do these individually just in case you choose to as well. That's negative 4.9 times 0.612 squared. I actually have a squared button on this calculator. That's negative 1.835. I've got 6 times 0.612 here. That gives me plus 3.672. And I still have my plus 0.6. Then I can combine these, negative 1.835 plus 3.672 plus 0.6. I end up with an answer of 2.437. Now, this question was in meters per second, so the maximum height of this projectile was just 2.4 meters. But the point of the word problem was that you can find the vertex of this standard form parabola by either completing the square or using some other shortcut you might know, like getting the axis of symmetry with negative b over 2a and plugging that x or t value back into the original equation to get h. You did it. I knew you could. Best of luck.